Hello and welcome to this new ArcSight video. We'll continue our discussion with the ArcSight Marketplace. In the previous video, we showed together how to access the ArcSight Marketplace and how to download one content which was the brute force logins, and we saw the value of downloading this content back and importing it into ArcSight, and how was the return that we got, how fast was the return we got from this fantastic content back. And in this session, we will show another interesting content back that is now mandated by most of the regulators, security regulators, that you need to monitor on the operating system, the Windows operating system level. So now the normal security Windows logs that you enable is not enough, and you need to dig more into the operating system and get more details about the process creation and the process level, to catch the sophisticated attacks that are taking place on the operating system. So Micro Focus has developed some software called Sysmon. It's a free software you can download from Microsoft. So here, if you go to the on Google, or if you go to this URL, docs.microsoft.com/en-gb-sys internals download Sysmon, you will find the latest version that released a few months, 1 month back, actually in 11th of December. The latest version is Sysmon version 10.42. So if we read here, the system monitor, or Sysmon, is a Windows system service and device driver that, once installed on a system, remains resident across system, reboots to monitor and log system activity to the Windows event log. It provides detailed information about process creation, network connection, changes to file creation time. By collecting the events it generates using Windows Event Collection or SIEM agents and subsequently analyzing them, you can identify malicious or anomalous activity. So it's very crucial now by all regulators they mandate it for all the enterprises to install this software and collect its logs into their SIEM solution. So fortunately, Micro Focus released this Sysmon content back that we can install on ArcSight ESM, and it contains a lot of dashboards and use cases that can help us visualize the Sysmon logs coming to ArcSight ESM. So all we need to do is to search for the Sysmon back. Yes, ArcSight Sysmon framework, and it requires also some flex connector, because by default the Sysmon logs are not parsed by the Windows native connector, so we need to also get the flex connector. So first we will go to this one. So now we can see the Sysmon framework. It's actually developed by one of Micro Focus partners, which is SOC Prime. And the framework, we expect to see some rules and dashboards to visualize the security checks on Sysmon events on Windows hosts. And here some description, and the minimum requirement here is version ESM 6.9. And it's also telling that you need the Flex connector that you can download from GitHub here, and it's already included in the Sysmon framework that we can download. So I already downloaded this. Okay, and here I already downloaded the SOC Prime Sysmon framework, Remember this one we downloaded and we extract and imported already in ArcSight. This one I extracted here, and you can see here the Sysmon Flex Connector Master is already included as well. So basically the Syslog Flex Connector is two things, a categorizer and parser override. So the categorizer is included in a folder called ACP, and it's actually like that. It should be ACP categorizer current Microsoft, and if we edit this one, we can see the categorization or the categorizer of file, which is it's like the categorization process that we use to understand this task is actually performed by the smart connector to map specific logs to the categorization of the ESM schema, like telling the for example, if we see this one Sysmon task, Sysmon create process, this is the keyword that exists in the process creation logs. So we map this category device group into set event. So this is the key. This is the key that this is the key event device event class ID. Sorry, this is the key. When we see this key in the log, the raw log coming to the smart connector, okay, we set this event fields in the ESM schema. So this is the key, and this is the action that we will do once we see that key in the log. So if we see the key Sysmon task, Sysmon create process, we will set the category object as a process. We will set the category behavior as execute start. For the category technique, we will leave it empty. For the category outcome, we will put success. For the category significance, we will put informational. For the event category device group, we will put operating system. For the category device type, again we will put operating system. For the category custom format field, we will put attack lifecycle install. And for the event originator, we will put source. And then for the second line, if we see in the log Sysmon file time, we will put for the category object, we will put resource file. For the category behavior, modify configuration, and so on. So this is the whole idea behind the ACB. Okay. We go back to the second folder is the FCB. This is the actual parser. Okay, so if we open this Sysmon SD KeyValue file reader properties, we can see here the parser. We will have a discussion in future videos about Flex Connector development. But for now, we just have a quick idea. This type of parser is called KeyValue. Okay, so basically it is a custom parser to be able to recognize the raw events coming from the Sysmon, and we set some some fields in the ArcSight ESM schema. So we first we define the vendor and the product as Microsoft Sysmon to make it different from the normal Microsoft Windows logs. And here some constants, and then here we define the time, and here we start to catch some of the fields coming in the raw events and translate them into some events to the fields of the ESM schema. So for example here, this is a regular expression to catch the hash value of the file, and we insert it into the file hash ESM schema field. And here the process ID, and we put in a field called device process ID. So all of this definitions are actually, you can find it on GitHub. If you go to GitHub, this URL, the ArcSight Sysmon Flex Connector, you can see here the definition and the mapping, field mapping summary between the, so as we saw in the key value bare flex connector, the device vendor and device product is set to Microsoft Sysmon, and here the file name, the file hash, everything as we saw in the file. So it's not our scope for this video to talk about the flex connector. I just wanted to get you the feeling about what is the value of this folder. So all we need to do actually is to copy these two folders. I will make copy for them, and I go to the installation of my Windows native connector. Okay, I go under current user and agent, and under this FCP, actually I can replace both FCP and ACP folders and put those, but instead of doing this, I will just take the content. So I will open the FCP, I will turn back to my extraction of the Sysmon Flex Connector master. I will take this one, Control C, and go here and paste it. So now I have the parser, okay, the parser for Microsoft Windows Sysmon under the FCP folder, which is the parser override folder of the Windows native connector. Also, I will take the content of the ACB, which is a categorizer, okay, and I will go to the ACP here, but I will not override this categorizer, so I will again go one step inside and take, and one more step inside. I will just take this Microsoft and I will put it under the categorizer current of the installation of the Windows native connector. So basically you need to put this folder Microsoft, which contains the categorizer, under your installation of the smart connector current user agent ACP categorizer current. You put this folder. So if you have a flex connector or a categorizer, for example, for your 40 gate firewall, you need to create a folder 40 gate and put the categorizer inside it. If you have a categorizer for your Palo Alto, for example, you need to create a folder here in the same path and name it Palo Alto and put the categorizer inside. If you have parser override, so you need to create a folder for under the FCP, like we did here for the Windows native connector, and so on. Okay, all we need now is to restart the connector. So from the smart connector point of view, we are ready to receive the Sysmon logs. So I will go to my services to restart the ArcSight. This one, this is my Windows native connector. So I will start it. Okay. Now we need to install the Sysmon itself on the PC where we will collect the Sysmon logs. So here for Microsoft, we'll download the Sysmon. Okay, and then I will take it and put on my device. Here. Okay, I will extract it here. Okay, so now I'm ready to install the Sysmon. Let's see what Microsoft is telling us how to install it. So an installation is simple. We just need to make like this, and then we pass to it a configuration file. So if we read in the GitHub here, there is a link for the excellent sample configuration file. Okay, so actually the Sysmon is collecting a lot of details from your operating system. So they make like a configuration file so you can tune what to collect and what to leave. Like I need to collect the process creation and file modification and ignore the others. So you edit this Sysmon configuration file, enable whatever you want and discard whatever you don't want. So from here we can download the Sysmon export.xml configuration file. So I'll take it from here. I think this one. And again, I will go to my PC. I will put it here. I'll extract. And then I'll just take this one and put it here. So now we are ready. We can have a look on this Sysmon config export.xml. If you look at it, you'll see that for example here, this is the process create. So this is a process creation. This is a file creation time, and so on. So we can see that this is a configuration to exclude here is excluding some of the Microsoft logs. Here is to include some others. See, a lot of details. This is the Sysmon event ID network connection, so it's including this, and here it's excluding for this one, and so on. So we will not dig into the details of the configuration, but I think this is the best practice to include. And as I said before, if you have any regulator in your country, in your environment, mandating specific Sysmon configuration, so ask him to provide it to you to include while you installing the Sysmon. So all we need to do now is to install the Sysmon. So I will open as administrator CMD, and I will go to that path. Okay. And from there, this my PC is Sysmon. My PC is 64. So I'm minus I, as we saw in Microsoft. They said here you need to Sysmon xe minus I the configuration file. Okay, so I'll go back. The configuration file name is this one, Sysmon config. So now we can start the installation. Okay, as you can see, the Sysmon service is now installed and started. We can verify by going to the services of this PC and check for Sysmon. You can see now it's running. So now from the PC, from the log source point of view, we have the Sysmon software up and running, collecting the logs. From the smart connector point of view, we have installed the Flex connector to be able to parse these custom logs and send it to the ESM. Now remaining is to install the content back from SOC Prime, from the ArcSight Marketplace, and into our ESM to visualize the security checks into nice dashboards and to have some rules that can give us good results. I just need to verify also on the endpoint on the Windows 10 PC that the Sysmon logs are generating. So if we go to Event Viewer, if we go to the event viewer of this PC, we can see here under the application and services, go to Microsoft and Windows, and Sysmon should be here. Sysmon, yes. Can see now Sysmon operational logs are now generating, and you see process creation. So for example, if we double click this one, we can see this process has been created, and what is the GUID for this one, and description, and a lot of good stuff that can help us. And the parent process, you can see the explorer.exe is the parent process of this new process. So actually there are very good stuff from SANS that define the legitimate parents for every process. So you can refer to this nice, I'll try to show this for you, SANS DFIR, I think for digital forensics incident response posters. So you can see here a nice um, posters by SANS that give you insights in the forensics of or defining nice use cases like which process is the see finding the evil on Windows system. So you can see here, for example, this is actually the link. You can take a note of this link, poster 2014 find evil.bdf. So if you go here, it tells you uh, some unusual Windows behaviors that you can define use cases based on this, and without the Sysmon package you will not be able to get these details about for example here it's telling you wmic.exe partial.exe execution used for remote execution. This unusual OS artifact malware does not need to be present on a system for it to be compromised. We need to also look for unusual OS-based artifacts that wouldn't exist on a typical workstation. When looking for program execution, focus on prefetch, and a lot of stuff like this can help you define nice use cases. Okay, so it can tell you as well which process, for example here, yeah, you can see this image path. This is the parent process created by an instance of smss.exe that exists. So tools usually don't provide the parent process name. So you can verify that if you see this process, you can verify the parent process and make sure that no malicious thing going on. So return back to the, now we verified the Sysmon logs are generating, okay. One step remaining that we need to modify the smart connector. Yes, we already put the flex connector into the relevant path under the native connector installation in the categorizer and the parser override, but still we need to update the smart connector. So I will go to the path for my Windows native connector, and I will run the run agent setup actually to update the configuration of the smart connector to point to not to point to just tell the smart connector that you will not only capture the normal security logs, which is there in the event viewer here, when you install the Windows native connector, you have the default option to read from security logs, to read from application, to read from system. But to read from the application logs, this nesting folders, these nested folders, you need to instruct the native connector to read these logs, and they are considered custom logs. So I will show you this in a minute. Yeah, so we will go to the modify connector parameters. As you can see, I only have the configuration for collecting security logs, and you remember when we make the use case in the previous video for the brute force, we only required the security logs, and we enabled, if you remember, in the Windows PC, we enabled in the local security policy, we just enabled the login events, okay? And also we enabled the if you remember for the computer management, we enabled to read these logs. So we need now to read some custom logs. Here you can see we can read system logs, we can read application logs, which are there in the normal event viewer. These are default. By default, you can read with the Windows native connector and doesn't require specific parser or custom parser. Yes, it can. It may require custom parser for specific cases, like if you want to read the description of this. These descriptions require some custom parser, but the normal logs, the ones you see here in the general tab for security application system, doesn't require custom parser. But if you want to read any log from this application services logs from these nested folders, you need a custom parser. Okay, so returning back. So returning back here, we select custom logs and enter manually. That's mean that we will define our log sources manually without looking up the Active Directory or any automated mechanism. So next here, my PC, the Windows 10 PC is already defined, and this is a standard account we defined and allowed in the event readers in the Windows 10 PC, and we selected only security. Now we will select custom event log, okay, and to make this we need to just point to this path. So if you go here, the Sysmon, we just need to I will show you. If we click here, properties, we just need to put this one. Here, see the full name, Microsoft Windows Sysmon Operational. We need to take this copy and we go here and paste it. That's it. And then press next. Okay, so Microsoft Windows is configured to collect events from one host. Next, now we are ready. We need to restart our smart connector again. So I missed this step when we put the ACP and FCP folders. So you can just do it once, update the FCP and ACP and update your smart connector, and then restart the smart connector service once. Now it's updating table parameters for the WNC, the Windows native connector. And after the update, we just restart the services. Meanwhile, we can go to the live Windows log and let's see if we get anything. Connector is now updated. Okay, exit and next. Okay, now I will restart. And I will return to the ArcSight. You can see the agent is starting. Okay, agent connected, and in a few minutes we'll start see new logs different from those that we used to see before. These logs uh, will have the not Microsoft and Microsoft Windows logs. It will have Microsoft and Sysmon. Let's wait for some time. So always the Windows log, the log source integration is your first step in any ArcSight implementation. This is actually the first thing that you sit with a customer and gather all the use cases, and after define your use cases or the required use cases, you start to narrow down the log sources that that are required to achieve these use cases, and then you work on them one by one to integrate them into ESM and validate they are coming correctly, and they are coming correctly, and with the right categorization, with the right parsing, and then you start to build use the rules itself, the dashboard, the reports, and everything. So now we can see, still this is old logs. We can make an active channel to focus on the Sysmon. Still we are getting only Microsoft Windows, the normal ones. Okay, let's go to the start to create any process or any, like open the calculator, exe, can refresh and see if this one is created. Yes, this one I think, let's see together. Yes, this is a calculator I just created now. So it should be a process create. Check here. So we just take a few seconds. So you can see here process create, calculate calc.exe. So if you go here, you see the it's now Sysmon, coming as Sysmon, and you can see the target process is calc.exe. Actually, if we dig into the inspect edit, we can see more details like what is the parent process. The parent command line is actually runtime broker. This one is the current directory, system32, and good stuff. Okay, so the content back from Micro Focus from SOC Prime will give us more insight into this Sysmon logs. Okay, so we need to import this into ArcSight. So if we go back to the SOC Prime, here is the documentation from SOC Prime. Tell us how to import this nice content back. So it gives you some insights on the detailed scenarios that it can catch, attack against key paths, detect cats when not written on disk, uh, process created from suspicious directory, suspicious partial combination, suspicious script executed. A lot of nice things, nice use cases. You will not be able to achieve these use cases without the Sysmon, but this is not the only use cases that you can achieve. You can develop your own, but this is a good start. It's actually contain around 25 rules, 13 filters, 3 lists. So first they ask you to deploy the Flex connector and then import the package SOC Prime framework 1.1.arp, and then check the filter Sysmon events and make sure that it covers all your perimeter devices, edit if needed, and then deploy the real-time roles because maybe they are not added automatically to the real-time. This is some guide on the use cases. So this is a use case attack against KeyPass. So you can see here they are checking for any source process name that executed with PowerShell.exe. So it's not normal that the source process is PowerShell. When you open KeyPass, the KeyPass is just a free software that you can store your passwords. But when you open it, you normally open it from Explorer.exe or from cmd.exe, but not from PowerShell. So if it's the source process is PowerShell, this means that some macro or some malware is there, and it try to call the KeyPass to make attack against it. And a lot of the definitions are mentioned here. Um, some process that is loaded from the 10 directories, so this could indicate some malware or some dropper in the 10 directories trying to launch from this not normal location to launch. And as I said, the posters from SANS, the DFIR posters are good reference to create many use cases based on the Sysmon logs. So going back to ArcSight, I'll try to import as we learned from the previous video. So you can go to the packages and you import. Remember, this was the brute force. So here I'll do the same. I will import. This time I'll import the SOC Prime ARP. Okay, so I import this one. It will ask me to install. Yes, next. And we are ready. So updating active lists. We are done. Great. So now we have Prime. It's actually doesn't rely on it's not based on the Activate framework of Micro Focus. Micro Focus, as we learned from the previous video, requires as a prerequisite for any package developed by them to this prerequisite package which called download groups. So because brute force attack content back was developed by Micro Focus engineers, it relies on this download groups. It has to be installed first, so it's called Activate framework. But for this SOC Prime Sysmon framework, it's developed by some partner to Micro Focus. They don't rely on these download groups, so it's coming in a different separate folder. Okay, so when we go to, for example, active channels, we can check the SOC Prime solution here. What is the Sysmon basic event? So the good thing that they provided us with an active channel with a filter that's ready to extract the Sysmon events. And if we check how this filter is defined, you can see it's looking for device product, device vendor Micro Focus, Microsoft, and the device product Sysmon, and type not correlation, which means they are looking for base or aggregated events. So you can see here it's very nice, and the field set is defined very nice, tuned to the Sysmon logs. We have process create successful, and the device address is our PC, the Windows 10 PC, and the user here is NXT, the device host name NXT-John Smith. We have the source username John Smith. We have the source process name, which is calculator. We see here the calculator.exe, destination username system. So you can see everything is here. Actually, if you need to know the label of this, if you double click, and go down here, you can see the device custom string 3 is actually, this is a current directory. So if you check the dot device custom string 3 dot current directory, so this is the label for this. You get to know that this is a current directory. This is a file hash. Okay, so if it's not the legitimate calculator.exe, it will have a different hash. So for example, you can build an active list and inserting in this active list the legitimate hash for the legitimate or the benign calc.exe. You put the correct hash, and if you see another calc.exe with a different hash, you can trigger an alert because this is a kind of file integrity use case. Without the Sysmon, you will not be able to get this kind of detailed information because the normal Windows logs is not providing these details. So basic use case that you can do with the Sysmon is to define an active list with all the correct hashes for all the important processes into your environment, like you have a golden image for your Windows master Windows image that you install in your environment, so you are sure about the hash value of each process, each critical process. So you can define an active list with all the critical processes and their corresponding hashes, and then cross-reference this active list in case anyone tried to work around these files. Uh, okay, and also if we wanted to know what this one is all about, again, we can check the label. See here is very long. What is this? Okay. You know this folder, it's called WinSXS folder. This is a folder used by the Windows operating system for exchanging files of the applications running in the memory. If you search about this, it's very detailed thing on how the operating system works. So advanced use cases can be done based on the Sysmon. Actually, it provides details that are not there in the normal logs. And in the device custom string 2, you can see the parent command line. In the device custom string 1, you can see the command line itself. So it's very, very detailed. So for example, you can see if this is generated by PowerShell.exe, that's not normal. But if it's coming from the command line, yes, this is normal, and so on. So let's see the dashboards. This is a Sysmon basic events, Sysmon framework correlated events. If we have any kind of correlation events generated by any rule, but I think we don't have till now because we don't have anything that is malicious going on. Let's go to the dashboards. Dashboards always provide good insight about the logs. So this one is Sysmon framework overview. We can see here, I think they need some time to be filled with the logs. Okay, so mostly all of this will take some time. Till then, let's generate some attack so we can see value for this Sysmon back. So I have here one Kali Linux VM instance, so we can start to play around. Actually, for those who don't know about Kali Linux, it's a distribution for a Linux distribution that comes powered with a lot of tools for hacking, and one of the famous tools is the Metasploit framework that you can use to launch attacks. But for sure, just to remind everyone that you should use this with a caution, just for lab purposes or for learning, not to attack anyone. So first we will create some fake software like fake calculator, and we will try to entice the user to download it, and it's actually a Trojan that will open a reverse TCP channel to get access to the victim Windows 10 PC. So this is the command. It's actually creating using the Metasploit MSF Venom command. You can create, and this is a local host. This is the my Kali Linux machine. This is the IP and the port, and the output, the executable I put inside the fake calc.exe. Okay, so after creation of this one, I will just copy it to I will start some Apache server, so the victim PC can connect to this fake website. So I will just copy this to var www.html, where the Apache service, this is the, yes, the Apache service. Then I will start the Metasploit framework. Okay, and then I will listen for any incoming connection to my Apache server. Hopefully the user tried to download this fake calculator.exe. So then first I will set my local host, and then I will my local port, and then the payload, and then exploit. Sorry, I need to first use the exploit, the multi-handler, and then exploit. Now the exploit is started, and it will be ready for anyone to connect. So I will go to the victim PC, and now I'll try to connect to this PC fake, to the fake website to download the fake software. You need to disable your Windows Defender if it's active. So now I will try to run this one. The Windows may tell you, the smart screen may tell you don't run this unknown publisher software, so I will run it anyway. So after running it, you see the session is open. So now it's able to make a reverse TCP back to the host, and you can see I'm able to see everything. I can make a shell. I have now access to the PC. So return back to ArcSight. Hopefully we get something interesting here. This is the Sysmon events. You can see process create. You can see file system created, file created. Lot of nice things coming. Actually, I missed to make this part, which is mentioned here, that we need to move the deploy the real-time rules. Okay, because by default the subprime guys did not copy the folder under the real-time rules, as the case for the brute force um, content back that was included in the real-time rules by default by Micro Focus. So we need to move this subprime or the Sysmon framework. I will move the whole folder here. Now the rules, see, moving one group, the rules will come under the real-time rules, subprime solutions, and the rules now are active. So we should start seeing something here. Anyway, we'll go back to the, as we see here, we already have a session. We can start the attack from the beginning. So here we can say exploit, okay, and wait again for a new connection from the PC. Let's do it again. I downloaded the fake calculator, and again I will try to run it. Yeah, session is established, the reverse session, and from here we can see we can get a shell. Okay, let's see if something triggered. Nothing yet. It takes time, just because the resources of my lab is not that high. It takes some time for the collector to parse and to see things. Anyway, let's do another attack. So if we go here, we go back here, I will just try to, as if it's a second stage of the attack after you get access, I will try to issue a PowerShell command to download some other malicious software. This is the second stage of the attack, drop some attack, some piece of malware into, see, by using the PowerShell. So I here create a web client to download this file from the same path, but now my love.exe, and I will download it in the temporary folder, and then from that folder I will start the process. So let's execute this one. All of this malicious behavior should be now seen by uh, the content back. We can see here network connection detected, and this my love should start to be seen here. Can check here anything coming, take some time. So now we can see here this PowerShell. When this PowerShell is triggered, make a process, created a process. Okay, and file created, you can see here this is a file, the temp file, this one. See this temp file created. Okay, and you can see here in the correlation event now we see malicious PowerShell execution and process created from suspicious directory. Okay, it's actually referencing this process create this malicious mylove.exe. We can see the process here, mylove.exe, and we can see here the malicious PowerShell execution actually found this from the command.exe, the parent command line. It executed this PowerShell, and in the framework here we can start seeing nice stuff. For the still Sysmon status, we have the one machine with Sysmon and suspicious events, and we can now have nice outputs for our case. So that's it for this video. I hope it was beneficial. a lot of it's little bit long, but it's I think a good reference for you guys to start using the Sysmon. And just to conclude, you need the Sysmon from Microsoft, the Sysmon software from Microsoft um, to be installed. The Sysmon from Microsoft to be installed on the PCs, the important PCs in your environment, like your CO PC, your the important critical assets, Windows assets, to dig into the logs and get this process creation file changes for integrity use cases. You need the Sysmon package. You need the Sysmon configuration master file, this Sysmon export to be to configure the Sysmon correctly and to select the IDs of the logs that you want. You need the yes, this is the Sysmon export.xml. You need the from ArcSight to download the SOC Prime package and install the Flex connector folders under the FCP for the for custom parser, and under the AUB, under the ACP, the categorizer, and you need to modify your smart connector configuration to run by running the agent setup to just point to the Sysmon operational folder in the event viewer. Yes, this path you get from here, and you finally you want to import the nice content back from SOC Prime into the ArcSight as we did here, and then you start to see nice stuff. Um, for sure, if you don't have any attacks going on, you will not see here any correlation, but at least you will see the Sysmon basic to make sure that your back is working fine. You can get the permission from your management to make some kind of this malicious thing with in a controlled environment in a test with a test PC to generate some stuff like this to with Metasploit to make sure your content is active and ready. This is good because one fatal mistake that you just forget to move the content to the real-time rules. So testing is always good to cover or to avoid fatal mistakes like this. And once you get the correlation rules file, so you are good to deploy this into production. So thanks for watching, and hope it was beneficial, and see you in next videos.